Hello everyone. So today we'll be discussing about gravitation. We'll be discussing that why the path of any object under a gravitational field towards a fixed point is always a ellipse, hyperbola or a circle or a straight line or even a parabola. Our main motive will be to discuss why this happens and derive the equations of the motion. So let's get started. At first, we'll be notifying you that we'll be discussing about polar coordinates, and one must know just the basic formula for polar coordinates is that F is equals to m r double dot minus r theta dot square into r cap plus 2r dot theta dot plus r theta double dot theta cap. So this is the equation of relation between force and acceleration of an object. And one thing to note that r double dot is d2r by dt2, r dot is dr by dt, theta dot is d theta by dt, theta double dot is d2 theta by dt2. This is a thing to know before proceeding. So now consider this green dot to be a fixed point O, and O produces a gravitational field of form Gm by r square minus r cap. Yeah, because it's towards the radial, towards the O, not away from O. That is why it will be minus r cap. Now consider a point P which is under the investigation that how it will move under the given force, if it has some velocity or not, whatever. Suppose the planet initially has some angular momentum L. Now I define L by m as some h, which is angular momentum per unit mass, which can be written as r square theta dot, because because it's constant, so this h is a constant. The force is minus GmM by r square r cap. Thus I can write that minus GmM by r square r cap is equals to m r double dot minus r theta dot square r cap. Now, similarly, 2 r dot theta dot plus r theta double dot is equals to 0. This is also another equation. Before proceeding, we'll be deriving some basic things to remember, to know before going to the problem. That is, r dot is written as dr by dt, which can further be written as dr by d theta into d theta by dt. D theta by dt is theta dot dr by d theta, which can be written as h by r square dr by d theta. I can write it as minus h by d theta into d of 1 by r, since dy by y square can be written as minus d of 1 by y. That's the same manipulation we did it here. Similarly, r theta r double dot is written as dr dot by dt, which can be written as dr dot by d theta into d theta by dt. D theta by dt is written as h by r square. Dr dot by dt is also written as d by d theta into minus h d of 1 by r by d theta. We can write it minus h square by r square d by d d2 1 by r by d theta 2. In this case, we'll assume 1 by r to be 1 by r to be equal to u. So I can say r double dot is equal to minus h square u square d2u by d theta 2. So minus Gm by r square. 1 by r square I can write it as u square is equals to minus h square u square d2u by d theta 2 minus r theta dot square. Theta dot we derived as h by r square. So I can write it h square by r to the power 4. R to the power 4 can r by r to the power 4 is 1 by r cube, and 1 by r cube can be written as u cube. Dividing the whole equation, first of all, cancelling out the minuses and dividing the whole equation by h square u square, will get gm by h square is equals to d2u by d theta 2, here I guess I missed a 2, plus u. Now this equation looks familiar. Exactly, it looks the same equation as we saw in SHM. But instead of d2x by dt2 plus x is equals to c, we get here theta, right? So accordingly we have to set the variables. We'll get u is equals to gm by h square plus c cos theta. I assume c to be something like gm by h square e, where we'll get to know what is e in the later stages of the lecture. I can say 1 by r to be gm by h square into 1 plus e cos theta. From here r is equals to h square by gm upon 1 plus e cos theta. If you remember that the equation of a conic in polar coordinate system is written as r is equals to a by 1 plus e cos theta. Now if e is greater than 1, it will be hyperbola. E is less than 1, it will be ellipse. E is equal to 1, it will be parabola. Similarly, E equal to 0 will give you circle. So we derive the equation of motion under gravity.